Leetcode problem 2096, step-by-step directions from a boundary tree node to another. So for this problem, we are giving two nodes, but it is not the node itself, we are giving the value of the node. So we are giving the root of the boundary tree with n nodes, so each node is uniquely a set value from 1 to n. So that means all the values of the node is unique. And we are also giving an integer start value representing the value of the start node. So this is going to be the start value. So this is going to be node 3. And we are also giving a destination node, destination value 6. So that's going to be the destination node. So what we are going to do, we are going to return the shortest path from the start node to the destination node. So for example, from this node 3 to node 6, so there's going to be a path. It's going to be like 3, 1, 5, 2, and 6. But while we go up, we're going to get a value of u and u. It means up and up. And then while it goes down, we need to record it is right or left. First of all, it's going to be right and then left. So we're going to return such kind of characters. So they're going to be always 3 characters, u, r, and l. Yeah, but so how can we solve such kind of problem? So normally, I think if we find such kind of problem, we have two nodes, 3 and 6. So the obvious way is that why not just find the lowest common ancestor? So for example, this is 3, this is 6, and the lowest common ancestor is going to be 5. And then, since we've already found the lowest common ancestor, we just need to start from this 5 and use a BFS to check if we can go through this 3 and if we can go through that 6. So while we are using the BFS, we're going to record the left or right. So at the left side, so this is going to be L and L. At the right side, so we're going to record this is going to be R and L. So this is going to be the final result. But from the left side, this LL, we're going to turn this LL to U and U. And at the right side, because this root will go to the destination, so we will not turn anything. It is going to directly be R and L. So the final result is going to be U, R, and L. Yeah. This is also easy. We just record while we find the start value. For example, this is going to be node 3. We're going to turn those values, no matter how many values, we just need to record the length of the string. So for example, LL, so the length of the string is going to be 2 times U, it's going to be double U. And at the right side, we just need to record all the strings, like R and L. Yeah. So let's just use this kind of idea to solve the problem. First of all, let's just try to calculate the lowest common ancestor. So normally I'm going to use a DFS. So I'm going to check if not node, it means the node does not exist. So I'm going to return a none, and then I'm going to check the value if node dot value inside the start value and the destination value. So I'm going to return the node, and then I'm going to check the left and the right. So it's going to be DFS node dot left and DFS node dot right. And then we're going to check if left and right, this means at the left side we have our node, at the right side we also have our node. It means definitely we find two nodes, so we're going to return the root node. Yeah, so this is for example 1. So for this node 5, at the left side we find node 3, that is inside start value and destination value. At the right side, we find node 6 that is also inside the start value and destination value. So we're going to return this node, and this node is going to be node 5. So if we cannot find it, we just go to the left or go to the right, because we are sure definitely we can find two values, the start value and the destination value. Definitely we can find the lowest common ancestor. So we can go to the left or go to the right. So if we cannot find it, so we're going to go to the left or we're going to go to the right. Definitely we can find a node. Yeah. So this is for the DFS to calculate the lowest common ancestor. So now the second step is that we're going to calculate this lowest common ancestor. So we're going to define it as a root node. So this root node is going to be equal to DFS with root. And now I'm going to prepare two results. It's going to be two strings. So the result of 1 going to be at So the result 1 gonna be recorded this like UU. It goes from bottom up. Yeah, it means from up to down, from up to bottom. Yeah. Yeah. So the result 1 will be just recorded from the start value, from the root node to the start value, and result 2 just record the path from the root node to the destination value. Now I'm gonna prepare a queue. So inside I will give a dequeue, and I'm gonna use a tuple with the root and the path. So I'm gonna give an empty string. Now I'm gonna check the queue. So while queue, so node and path gonna be equal to q dot pop left. So now we're gonna check node dot left. So queue needed to append a tuple with node dot left and path plus, since we go to the left, we're gonna plus L. And similarly, if there's the right, so queue needed to append node dot right. So the path gonna plus this capital R. Yeah. So finally, we need to have a check. So we need to check the node value. If node dot value equal to start value, so this means we've already fired the start. Yeah. So if we fired the start, we just needed to record it in result 1. So it's going to be the length of the path and times u. We just needed to check how many u's. So for example, from 5 to 3, it's going to be, the path going to be something like L and L. So the length of L going to be 2. 2 times u going to be double u. From the left side, it goes from the bottom up. And then we needed to check the result 2. So if not node dot value equal to the destination value, so we're gonna record it as a result 2, so it's gonna equal to the path. Yeah. So finally, we just needed to return result 1 plus result 2. Now let me just run it to check if it works. As you can see, it works. Now let me just submit it. Yeah, as you can see, it passed all testing cases, and I think the speed is okay. So the first step is going to be the BFS to calculate the lowest common ancestor, going to be 5. So the second step is going to be BFS. We just need to check the path. So BFS is normally used to check the path. And I think that's all for it. Thank you for watching. See you next time.